Have you ever thought that we can't put out fire without a substance? And is it possible? Well, that's what we discuss in our research entitled Invisible Fire Extinguisher. My name is Maria Novena.
And I, Keisha Emanuela.
We are from Untung Suropati Katolik Senior High School, Sidoarjo. Who doesn't know fire? Of course, we have often seen and used fire. We really need fire in our daily lives. However, careless use of fire can start a fire. One of the fire with a high level of danger is fires in class space. Apart from being difficult to reach, it can also cause people inside to run out of oxygen. So far, in our country, Indonesia, we have extinguished fires using a special tool called apex. However, fire extinguishers can only be used according to the material being burned and cannot be used carelessly. Therefore, we want to introduce a new solution for extinguishing fires by using low-frequency sound wave. Based on the previous background of study, the problem formulation we got are 1. Can sound wave be used to put out fires? What sound wave frequency is effective for extinguishing a fire? What is the relationship between the frequency and intensity level of sound wave on the fire extinguishing process? And how does the intensity of the fire affect the frequency and intensity level of sound wave that are effective for extinguishing the fire?
In this study, we use low frequency, namely 20 Hz to 70 Hz, with an intensity level of 70 until 100 decibel, with a margin of 5 decibel. The fire sample we used came from burning methanol. The fire sample had a temperature of approximately 1870 degrees Celsius. There are two fire samples we used as follows, and each sample received exposure to low frequency wave. For each frequency treatment, the sound intensity level is increased. We did this to observe whether the fire went out or remained burning when it received treatment and how long it took for the fire to go out, calculated from the sample receiving treatment. The way it works is by preparing the sound source according to the frequency and the intensity level that we want to test. And then we set the distance between the sound source and the fire sample and the sound level meter. And then we turn on the sample. And then the sound source is activated. This research showed that sound wave with certain frequency can affect the fire. Sound waves are longitudinal waves consisting of density and strain that will have an impact on air particle density. Low frequency has the amount of density and strain becoming less and less each time. This causes the wave to get longer. A large wavelength will be more beneficial because the strain have a wider interval, so that the density of air particle in that area is lower. Low air density will disrupt the oxygen supply in the combustion reaction and will have an impact on extinguishing the fire. We can see in the graph for sample 1 and 2 that a decrease in sound frequency will have an impact on reducing the level of intensity needed to extinguish the fire sample. Meanwhile, the sound frequency above 75 Hz with an intensity level of 70 until 100 decibel do not have a significant effect. Sample 2 has a larger geometric size than sample 1. The larger the geometric size, the greater the sound intensity level required. Both samples show the same pattern, namely at the frequency of 25 Hz, a lower intensity level is required to extinguish the sample. And next, to measure the amount of energy we use two parameters, namely the time and the intensity level of extinguished sample. From the following graph, it can be seen that a low intensity level will cause a large application duration.
It can be concluded that low-frequency sound wave can be used to extinguish fires. The sound wave frequency that can be used with an intensity level of less than 100 decibel is in the interval 20 Hz until 60 Hz. The lower sound frequency has an impact on the need for a lower sound intensity level. The greater the fire intensity is directly proportional to the required sound intensity level. Meanwhile, the relationship with the frequency is the greater the intensity of the fire. The lower the frequency needed to extinguish the fire. For further research, more adequate instruments are needed, especially loudspeakers, so that the size of the sample geometry can be more varied and the resulting graphic patterns are more varied.
So, that's all from us, and thank you!